Hello, I'm Randall Carlson. I'd like to welcome you back to another episode of Squaring the Circle. In recent episodes, we've been looking at the phenomena of hypervelocity impacts of comets and asteroids. We've been looking at the cosmic environment, close encounters that have come very close to Earth but not actually struck us. In the most recent episode, we looked at the big picture, the long range of impacts into the Earth, and we saw a gallery of craters that are the impact scars left over from these great impacts, also called astroblemes if they're not the classical bowl-shaped crater. In this episode, we're going to bring it a little closer to home, and we're going to look at the evidence for cosmic impacts within the last 10,000 to 12,000 years. This would be what we call the Holocene in terms of geological epochs. This is the period of time during which human civilization arose out of simple hunter-gatherer societies, foragers, and so on. So we see the shift over into sedentary lifestyles. We see the dispersion of languages. We see the first urban complexes. We see all of these kinds of things occurring in the early to mid Holocene. And what has been neglected in looking at models of human history and the rising and the falling of civilization is the potential role of cosmic impacts and encounters with things from space. So it's interesting that while conventional models of prehistory still dominate, there's been a whole lot of research over the last couple of decades that suggests that cosmic impacts have played a much greater role than has previously been recognized. So that's what we're going to start looking at in this episode. So I'm calling this one Hypervelocity Impacts in Human Civilization, Cosmic Encounters in the Holocene. So we're going to get right into it here, and I'm going to refer to an article that I actually came out way back in 2007 as the paradigm was beginning to shift. It was authored by Mike Bailey with the Department of Geography, Archaeology, and Paleoecology at Queen's University in Belfast, UK. And he is an expert in tree ring analysis. And he also spent a bunch of time looking at the evidence for climatic downturns and connected with evidence for cosmic impacts occurring or corresponding at the same time. So the title of this paper that he published back in 2007 in the Journal of Quaternary Science was entitled "The Case for Significant Numbers of Extraterrestrial Impacts Through the Late Holocene." And this is I'll just get into a little bit of it here. And this is what he wrote. "It almost seems that there is a reluctance to take craters seriously, given their potential importance in assessing impact hazards. It is surprising that their identification is not afforded more importance by nation states. In general, they are not regarded as national priorities, and their study is left to the whim of individual researchers. Despite that, there is a reasonable evidence for at least a dozen craters on land within the past 5,000 years. That would equate, allowing for the greater area of the ocean, to a minimum of 40 notable impacts on the entire Earth's surface in this time interval." Now, the points he makes here, way back in 2007, are still true. There's still not enough importance being attributed to this phenomena. And of course, one of the reasons for that now is the dominant paradigm is anthropogenic climate change. And I've been making this point all along, that if we start looking at natural triggers for climate change, whether it's volcanism or changes in oceanic circulation or changes in solar variability or in the galactic ray bombardment, we could go through a whole list of potential other influences on climate. But the point is, or cosmic impact, the point is, though, is to talk about these things in diverts attention away from the dominant paradigm, which again is anthropogenic climate change. And they would be distractions from the imposition of that particular narrative into the discussion of, particularly of policy. And I think this is probably one of the main reasons for the neglect of some of these other factors, which I would consider two of the most important, being the impact phenomena and solar variability. We'll be talking about solar variability in future upcoming episodes. But for now, we're focusing on the phenomena of impacts that could be by asteroids or could be by comets or cometary related debris in the Holocene. So this would have been cosmic phenomena that could have directly affected human societies, human cultures, and human history. So Bailey goes on and he says, in general terms, people who thought that impacts from space were mostly inconsequential were the products of earlier 20th century thinking. According to the vast majority of 20th century historical and archaeological researchers, there is no evidence for anything from space having had any effect on human populations in the whole of the time since humanity became literate. That is, within the last 5 millennia. Obviously, if you live on a planet which has not been hit by anything within, say, 5,000 years, there's little to worry about in the less than century lifespan of a typical human. Presumably, by extrapolation of this thinking, impacts by comet fragments would be inconsequential. In July 1994, however, it was observed that the impacts on Jupiter were indeed huge, the largest releasing the equivalent of millions of megatons. Now, I'm sure a lot of listeners do remember the event of July 1994, which was the impact of the fragments of comet Shoemaker-Levy 9, 21 fragments to be exact, that plunged into Jupiter. And there was a lot of discussion and controversy leading up to that event as to whether the consequences would be profound or not. And it turns out that they were. Like Bailey says here, millions of megatons were released. Had that event occurred on Earth, had those, say, 21 objects struck Earth in July of 1994, we would pretty much be extinct right now. Okay, so that's kind of a big deal. Then there was another paper around that time that came out at the Cambridge Conference Correspondence, and it was entitled, now this was at a presentation at the annual meeting of the American Association for the Advancement of Science. Dr. Benny Pizer of Liverpool John Moores University presented there. And what he did is he presented evidence suggesting that more than 500 impact events of extraterrestrial origin have punctuated Earth during the past 10,000 years, which comprises most of the Holocene. The great majority, or 70% of these events, have been of the Tunguska-type class of atmospheric impacts, with an average energy yield of between 20 and 100 megatons of TNT. Now, you will recall, I hope you've seen the episodes we did on the Tunguska event. You'll know that the general consensus at this point is that the energy released during the Tunguska event was about 15 megatons, which was about the size of the largest hydrogen bombs tested by the United States back in the 1950s. So anyways, Pizer is making the point that the majority of these impacts were of the Tunguska type. Now, you remember that Tunguska did not create a crater because it was an airburst. And airbursts will create tremendous havoc on the ground in the immediate area of the burst, but they don't leave the kind of lasting imprints that you would find from a direct impact into the ground itself, which creates a crater or a classic bowl-shaped hole in the ground. So what he's suggesting here is that more than 100 surface impacts, including more than a dozen oceanic impacts, are believed to have repeatedly devastated whole regions, small countries, and early civilizations around the globe. In a worst-case estimate, Dr. Pizer said that up to 8 climatic downturns detectable in the geological and climatological records of the Holocene may be directly associated with multiple impact events. Okay, now let's reemphasize that. Up to 8 climatic downturns. So in his research, he sees a direct link between climatic phenomena, climatic variability changes, and the incursion of cosmic objects, whether they're direct impacts or air bursts, okay? This is important, and this is the thing that wants to be downplayed and de-emphasized by the proponents of the establishment narrative, which is that we're only supposed to be looking at human causes for climate change, okay? He goes on here, he says that episodes of increased cometary or meteoric activity punctuating societal evolution should be looked upon as potential agencies determining the rise and fall of ancient civilizations. Both the emergence and the collapse of human cultures, the Pleistocene-Holocene transition, and the Neolithic Revolution, the onset and collapse of the Bronze Age civilizations, which is something we're also going to be addressing in greater detail in future episodes, and even the collapse of the Roman Empire may be associated with episodes of increased cosmic activity and multiple impacts that may well have included incidents of cosmic dust loading. Now, this is another byproduct of cosmic encounters, is the incursion of dust into the global atmosphere. Now, what that's going to do, of course, is make the atmosphere more opaque. It's going to reflect more sunlight back into space, and it's going to cause a general decline in temperatures, which can have devastating consequences, as we've seen during several of the episodes of climatic downturn that have led to agricultural collapses, which in turn have led to famine, and which in turn have led to the onset of disease pandemics, because people, when they're malnourished, they are not getting enough nutrition and their immune systems get weak. But again, this is not something that is supposed to be included within the mainstream discussion. So he goes on to say that while most of these impacts occurred over unpopulated areas of the globe, there are historical accounts about devastating cosmic catastrophes. According to a number of Chinese records, about 10,000 people were killed in the city of Qiangyang in 1490 AD due to the breakup of a small asteroid. Then he goes on to say about a dozen hypervelocity impact craters that date from the Holocene period, that is, since the end of the Ice Age, have been discovered to date. The majority of impacts, however, that occurred during this crucial period of societal evolution have not been detected yet. According to Dr. Pizer, the 14 known impact craters most certainly paint a rather deceptive picture of our past. The fact that no massive impact crater dating to the Holocene has been detected has led to the belief that no hemispheric or global impact disaster can possibly have happened. However, this is a widespread delusion, and that is directly quoting Dr. Pizer. And yet, there is still a regrettable lack of interest in the scientific community to scrutinize the Holocene for major impact events, and that is still true to this day in 2024, which to me is an oversight that could have ultimately very dire consequences if we don't become more aware of the cosmic environment of which our planet is a part and its role in human societies and civilization on Earth. So I am now going to go and show you a map that is the distribution of known impact sites just within the past 5,000 years. So let's see if we can get this here. I would like to mention that one of our original sponsors at Cosmographia, CBD from the Gods, is following us here to our new podcast, Squaring the Circle. As many of you know, I've been using their products for going on 4 years now, And having tried a number of CBD brands, CBD from the gods seems the most effective for my needs, which is primarily as a sleep aid and as a remedy for inflammation and associated pain. I use both the oil and the salve. My wife also likes their products, especially the salve, which alleviates the pain in her hands, which is the result of working for years as an electrician. If you've been thinking about trying a CBD product and experiencing the benefits for yourself, give CBD from the gods a try. To learn more and see their product line, check out cbdfromthegods.com. Any purchase of their products helps our efforts here at Squaring the Circle to realize our goal of making this world a better place. Thanks. Let's see, let's just roll down and we will get to that map. Here it is, right here. Okay, so you can see here, this is I think there's at least 14 of them here. Now, these are all within the past 5,000 years, which is not even half the Holocene, right? Some of these would have been only local or regional. Some of them may have had global consequences. We're going to look at some of them in more detail, and then in the next segment here, we are going to really unpack some of these particular events and look at the long-term consequences. We're going to examine whether or not they had a role to play in the evolution of human civilization. So we'll begin here by looking at a very interesting example. This was recent grazing impacts on the Earth recorded in the Rio Cuarto crater field in Argentina. Let's look at this together. The most probable angle of a meteoroid impact on a planet is 45 degrees, and an impact at 15 degrees from the horizontal or lower is as likely as at 75 degrees or higher. Yet little direct evidence for oblique impacts exists on the Earth. Oblique meaning a very shallow angle of approach, okay? Unless the impact angle is very low, any asymmetry created during the initial transfer of energy from impactor to target is lost as the crater is formed. In other words, you can come in at an angle and the explosion is going to create basically a round crater, not necessarily an elliptical one. And the shallow crater, moreover, the shallow craters formed by oblique impact are more easily obscured by subsequent erosion. During routine flights 2 years ago, now this is from Nature, the journal Nature in 1992, so this has been a while now since this discovery. One of us noticed, and that was Ruben E. Lianza, noticed an anomalous alignment of oblong rimmed depressions, 4 kilometers by 1 kilometer, on the otherwise featureless farmland of the Pampas in Argentina. We argue here from sample analysis and by analogy with laboratory experiments that these structures resulted from a low-angle impact and ricochet of a chondritic body originally 150 to 300 meters in diameter. Now, 300 meters in diameter, that's going to be about 6 times greater diameter than Tunguska. So you can extrapolate up from that, the energies released during this thing might be on the order of 80 to 100 megatons. So this would have been a regional disaster here. That goes on to say the Rio Cuarto crater field provides a rare opportunity to investigate energy partitioning associated with large-scale oblique impacts and to explore the complex interactions between impactor, target, and atmosphere previously only observed in the laboratory and preserved in different planetary settings. The size of crater A indicates that the impact body was about 150 meters in diameter, resulting in an estimated energy release of 350 megatons of TNT equivalent. Okay, so this was, I was even off by an order of magnitude here, 30 times larger than the 1908 Tunguska event for an assumed impact velocity of 25 kilometers per second. The age of the emplaced loess, which is a type of topsoil, the excellent preservation state of the smaller craters, The preserved glassy sheen on the impact and the state of the recovered chondrite all suggest an age considerably less than 10,000 years. Consequently, it is conceivable that this event was witnessed by early inhabitants of South America. So this shows the recent grazing impacts on the Earth recorded in the Rio Cuarto crater field, Argentina. Okay, you can see this is like, imagine a gigantic version of skipping a stone on a pond, and you kind of get the impression of what happened here. And then from the aerial view above, you can see how elongated these scars actually are. So, and then above the black and white photograph, here's one of the smaller members of the Rio Cuarto crater field, approximately 250 meters across. The ridge and grooved terrain extending to the southwest is typical of craters formed by a tight cluster of small projectiles in the laboratory. Okay. And in the next one, we have here a specimen of the Rio Cuarto Holocene impact glass melt. And this is from the study by Peter Schultz, 2014. This was a follow-up on this and the archaeology of cosmic impacts. This is lessons from 2 mid-Holocene Argentine case studies. There's another one. I don't think we'll have time to talk about that in this particular episode. But let's go on. There is more. This is a very interesting case. The 1930 August 13th Brazilian Tunguska event. And so this is from the scientific journal, The Observatory, and this information was provided by the NASA Astrophysics Data System. And Mark Bailey was also involved in this, the authoring of this particular report. So let's look at this. A brief note in the Journal of the International Meteor Organization, citing an article by Kulik. Remember him? Kulik was Leonid Kulik that it's referring to here, who was the first scientist to reach the Tunguska, the site of the Tunguska cosmic event. So this is citing an article by Kulik in a popular Russian scientific journal in 1931, and it has drawn attention to a possible Brazilian twin of the Tunguska meteoroid explosion in 1908, which devastated nearly 2,000 square kilometers of forest in an area near the Podkamennaya River, about 70 kilometers from the central Siberian town of Vanavara. Kulik's article contains information published in the Daily Herald of March 6, 1931, which itself refers to a report originating from Catholic missionaries working in Brazil and published in the newspaper La Osservatore Romano. There is currently much interest in the frequency and the possible hazards to civilization posed by impacts with the Earth of relatively small fragments of comets or asteroids in the 10 to 100 meter Tunguska object size range. And since neither the report in the Daily Herald nor that in La Osservatore Romana are readily accessible, we thought that a summary of the former and a complete translation of the latter would be of interest to readers of the Observatory. Now, we're not going to do the complete translation here about that, but we'll get into it enough here that you can sort of get the gist of it. So this is the archaeology of cosmic impacts. Let's see, this is a little bit out of order here. We're supposed to have been backed up by the Rio Cuarto before we jumped into the Brazilian Tunguska. So we'll just look at this while we're here, and then we'll go forward. Cosmic impact is a category of natural catastrophe neglected or misunderstood by most archaeologists in reconstructions of past population dynamics. Let's emphasize that. It's a type of natural catastrophe neglected or misunderstood by most archaeologists in reconstructions of past human population dynamics. We discussed the nature of impact by asteroids and comets and what is known and theorized about the Quaternary period impact record. Now, Quaternary, we're going back 2.6 million years. We're not focused on that big of a span of time in this episode. We're looking at the last 10 to 12,000 years. As case studies for our exploration of how archaeological method and theory can be productively applied to the study of cosmic impact, we focus on two confirmed Holocene asteroid impacts in central and northeastern Argentina. One was the Rio Cuarto, which I just introduced you to, and the other is the Campo del Cielo, both likely dating between 6,000 and 3,000 years before present. We model and assess the potential destructive effects of these impacts on contemporary hunting and gathering populations using several lines of evidence. The search for Quaternary period cosmic impacts, along with the documentation of the effects of confirmed cosmic impacts on human populations, particularly of those organized in small-scale social groups, represents a challenge and a key opportunity for our future archaeological research. And then I have a quote here by one of the preeminent scientists studying impact phenomena, and he says impact cratering is the most fundamental geological process in the solar system. And we know that now in a large-scale geological. We also suspect that in a paleontological context, it is also one of the most fundamental processes. What we're not now yet accepting is the idea that it may be one of the most fundamental processes in human civilization. And this is what I'm trying to get the attention and the discussion to shift over away from the dominant politically contrived narrative to be looking at this phenomena, that it may have played a very important role in the evolution of human civilization on this planet within the last 10,000 years. So now let's get back to the Brazilian Tunguska. Okay, so this appeared in the journal New Scientist back in 1995. They're posing the question, did a falling comet cause rumble in the jungle? The diaries of a Catholic missionary could reveal the cause of a catastrophic explosion which devastated hundreds of square kilometers of the Brazilian rainforest 65 years ago. Father Fidel de Alviano wrote a report on the explosion in 1931 for the papal newspaper La Osservatore Romano. His article, which was recently rediscovered by a British astronomer, describes the blast in graphic detail, but fails to mention vital features that would help to identify the cause. The missing clues may be in the priest's voluminous diaries, which are held in the Vatican Library. The Brazilian Tunguska came to, this is Mike Bailey again, to Bailey's attention after he read a reference to it by Nikolai Vassiliev and Gennady, I'm probably butchering his name, sorry if you're still around and you hear this, Gennady Andreev, in a 1989 issue of the Journal of the International Meteor Organization. The Russians referred to a 1931 article by Leonid Kulik of the Soviet Academy of Sciences in Moscow, the first man to investigate the Tunguska event. Kulik mentioned reports in Western newspapers, including the British Daily Herald, of a massive explosion in Brazil, but neither he nor Vassiliev or Andreev had access to Western newspapers. Bailey did, however. He looked up the Daily Herald story only to discover that it was based on D'Alviano's article, for which it gave no date. On a subsequent visit to Rome, Bailey obtained microfilm copies of La Osservatore Romano from the period. Thank you for that, Mike Bailey. Back at Liverpool, John Moores University, where Bailey was then a researcher, he was being work-shadowed by two local schoolboys. He set them searching through the 5 reels of microfilm. On the first day, Damian Markham and James Scriven found a headline referring to bolides, or exploding meteors. In the article, based on his interviews with terrified locals, D'Alviano describes how at 8 a.m. on the 13th of August, 1930, in the upper reaches of the Amazon, close to the border between Brazil and Peru, the sun suddenly turned blood red and everything was plunged into darkness. A fine white ash rained down, followed by an ear-piercing whistle. Finally, 3 balls of fire streaked across the sky and exploded, creating earthquake-like shocks. The explosions were heard hundreds of kilometers away, and the forest burnt for months afterward. Eyewitness accounts of the fireballs. Now, this is from another report that appeared in the journal Planetary and Space Science of January 2011, Caraca, a probable mini Tunguska. So, eyewitness accounts of fireballs and explosions in the Caraca area, Brazil, in August 1930 led to the suggestion that a large meteorite had fallen. It was later discovered that a seismic event had occurred on the same day and approximately the same hour as the Caraca event and in the same area. You will recall from our discussions about the Tunguska event that there was a 6.7, or was it 5.7, Richter scale earthquake associated with the airburst of Tunguska. Could this have been related in the same fashion here? I think it's likely. Otherwise, it's purely a coincidence. But an interesting coincidence nonetheless, because as we explore into this phenomena deeper, we're going to find that the correlation between these type of cosmic events and a terrestrial response in the form of a seismic response or an earthquake actually seems to be a fairly regular occurrence. There is also a description of going on here. There's also published description of a circular feature of about 1.2 kilometers diameter in Landsat images of the river Caraca Basin. It has been suggested that this feature could be the trace of an impact crater produced by the Caraca event. So, in August 1930, Father D'Alviano went to the Caraca River near the Brazilian-Peruvian border to carry out his annual apostolic mission. There, he discovered that the local people were terrified by fireballs and explosions that had occurred a few days before his arrival, and that had led them to believe that the world was at an end. And we will recall that this is exactly the response of the Tungusi people in the area of the Tunguska event, is they thought that this was the end of the world. Hundreds of eyewitnesses reported to the Catholic missionary that around 0800 hours on August 13th, 1930, a fine red dust began to fall onto the forest and into the river. Then people heard several ear-piercing whistles that became increasingly loud. Fishermen on the river could see the fall of large fireballs. There were 3 distinct explosions, each causing earth tremors. The ash continued to fall until midday. Father D'Alviano concluded that a meteoroid had exploded in the Earth atmosphere, and a note to this effect appeared on March 31st, 1931 in the Vatican newspaper. So, where is this one now? The status of this looks like it was a Tunguska-type event. Maybe not quite as powerful, but interestingly about this one, there were 3 fireballs reported. So, probably what happened here is you had a single object coming in, and then as it entered in the atmosphere, it broke up into 3 parts. And then the offspring of that was the 3 fireballs, which apparently exploded in the atmosphere, unless the depression that it referred to in the previous quote was in fact a crater, and one of them actually struck the ground. But this has not been confirmed because of the fact the rapid recovery of the rainforest and the jungle and so on has made it very difficult to go in there and determine whether or not it is actually an impact crater. So now we're going to go on to some more potential impacts during the Holocene. The next one is the Eagle Station impact site. This report appeared just recently in the North American Archaeologist in 2023. Now, Kenneth Barnett Tankersley, I've met him. He was one of the presenters at the Cosmic Summit in 2023, and he's done some very important work associating cosmic impacts with the Hopewellian culture in the Ohio River Valley region, and we'll get into that. So in the abstract, it says the Eagle Station impact site is located along Eagle Creek in Carroll County, Kentucky. Palisites, we'll talk about those, 23 centimeters to less than or equal to 3 millimeters, are a rare form of stony meteorites, and they occur in the late Archaic cultural period stratum with heat-altered flaked stone artifacts, carbonized plant remains, and fire-cracked rocks. A calibrated accelerator mass spectrometry radiocarbon age of 3,824 years before present to 3,593 before present. So that would be 1875 before Common Era to 1644 before Common Era. On the palisite-bearing stratum demonstrates that the impact event occurred during the late Holocene. The habitation site was abandoned after the impact event, and the site was buried within 200 years by alluvium. The Eagle Station impact site increases our understanding of the frequency of late Holocene cosmic impact events and their possible influence on ancient cultures. Despite the scientific evidence of the Eagle Station palisite-type locality, the age of the impact event has never been chronometrically determined. There is a growing body of evidence that ancient cosmic events such as asteroid impacts, comet airbursts, and meteor falls have impacted ancient cultures of various ages worldwide. In North America, Hopewell archaeological sites associated with the Middle Woodland culture period contain more meteorites than any other cultural complex. More specifically, Hopewell archaeological sites contain an anomalously high concentration of palisites, the rarest form of meteorites. Okay? Then we'll move on to yet another impact site. So this was also from 2023. So this is recent stuff. You can see that these discoveries are ongoing. For the last 25, 30 years since scientists started really taking a closer look at the Holocene period, which again is focusing on the near historical period, as opposed, let's say, to the long-term picture of the role of great impacts in Earth history and its effect, for example, on the rise and fall of mass extinction events, also the possibility of major climate shifts and geological boundaries being associated with great impacts. So this is evidence for a large late Holocene strewn field in Kiowa County, Kansas, USA. Now, a strewn field, basically, let's picture this. You got maybe a low-density object coming into the atmosphere and fragmenting, right? This is what Rio Cuarto was. It was a strewn field. You had multiple impacts of what was undoubtedly once a single object, maybe very loosely consolidated, maybe a very friable object, but once entering into the Earth's atmosphere, the frictional passage causes it to separate into multiple pieces, and then you have what's called a strewn field. Okay. Let's see what we say about this. There is evidence that Native Americans have transgenerational knowledge of past cosmic impact events that have been passed down through their oral histories and cultural traditions. The homeland of one Native American tribe, the Pawnee, in the Great Plains of North America, including Kansas. The Pawnee are known for the accuracy of their astronomical knowledge. Pawnee oral histories tell of a time when the stars flew and fell upon the earth. Now, I'll mention that back when I was the lead researcher for Fire from the Sky, which was a documentary that was funded and appeared on both TBS and CNN, back in 1996-97. That's when I first learned about the Pawnee and their quite remarkable knowledge of astronomy and their traditions of potentially cosmic impact. So let's go on here and see what Dr. Tankersley has to say in this particular report. The Brenham/Haviland meteor crater is just one of a of a plethora of impact features comprising a large, approximately 800 hectare, late Holocene age strewn field in Kiowa County, Kansas. More than 10,000 kilograms of pallasites, a rare class of stony meteorites, have been recovered from impact features and the surface of the strewn field. 6 AMS radiocarbon ages demonstrate that there is a 95.4% probability that the impact event occurred within a range of 1,497 or 1497 before Common Era and 419 before Common Era, and most likely between 754 and 419 before Common Era. The impact event is well described in Pawnee oral histories and illustrated in petroglyphs near the strewn field. The age and geographic extent of the Kiowa County, Kansas strewn field increases our understanding of the frequency of cosmic impact events on Earth and their influence on people and cultural change. Now, pallasites are believed to form between the silicate mantle or outer shell and the molten cores of a differentiated asteroid. The primary silicate mineral in pallasites is olivine, distinguishable by its greenish hue. The olivine crystals contained in the Marhalati pallasite are of such consistently high purity that they were adopted as a scientific standard for the composition of olivine, also known as the gemstone peridot. Gem quality peridot has been identified in multiple pallasite meteorites. Okay, this seems to be associated with these mid-Holocene, Hopewellian, Ohio Valley impact, or impacts if it was more than one. And so in this one, we actually have a backlit slice of the Fukang pallasite. And this is, you can see here, these are the olivine crystals. So what you've got is here's a very thin slice, and you've got it backlit so that the light is coming through it and illuminating the olivine crystals within the pallasite, the slice of the pallasite. And here we have cut, polished, and acid-etched pallasites collected from impact feature sample sites. This is multiple different ones. So this is still from the article Evidence for a Large Late Holocene Strewn Field in Kiowa County. But there's other examples of pallasites. However, as it mentioned here, they're rare amongst meteorites, which may have some interesting implications that we don't have time to discuss here for this episode. Okay, so going further into the evidence for an effect on the Hopewell culture. Now, remember, the Hopewell culture, in case you don't know, they're the ones who are associated with all the monumental earthworks and mound building structures throughout the Ohio River Valley and its tributaries, which is something we're going to be talking about in great detail in upcoming episodes. Not just the association potentially with impacts, but also the whole phenomena of monumental earthwork structures in itself, which is a pretty amazing thing and is worthy of deeper investigation. And it's something that has fascinated myself and some of my friends and colleagues for years. We've made multiple expeditions to examine these sites. We're planning actually future excursions to visit some of the monumental earthwork sites, maybe next year. So Tankersley's work, the Hopewell Cosmic Airburst Event, a review of the empirical evidence. He's done several articles on this. You can see this is I think this is available. You can download it online, I believe. Let's see a review. This appeared in the journal Airbursts and Cratering Impacts, just published in 2024. Now, I will mention that the archaeological community has taken great offense to this idea that there may have been impacts involved in the cultural and social evolution of these early pre-Columbian societies in North America. So it remains controversial, but I think that the weight of evidence is coming down on the side that yes, there have been actually these events that have affected the rise and fall of human cultures in the past, and the archaeologists might just need to man up and recognize that this is a feature that they're going to have to incorporate into their models of history and prehistory. But they're not too excited about having to reorient their thinking at all. And we find this pretty much across the spectrum of the archaeological establishment, although this is beginning to change. Okay, some of the kinds of proxy evidence found here, like the next image, is a scanning electron microscope, micrographs of iron and silicon-rich microspherules. This is from one of the Hamilton County, Ohio, the Turner earthwork site. And this is the kind of thing that is formed in the tremendous heat and pressures of impacts, is these type of microspherules here. And again, when we're looking into more depth and talking about the proxies, the means by which we prove or disprove the existence of a hypervelocity impact, this is one of the criteria we use, which is microspherules. Now, one of the sites that's being referred to here in the next image is quite interesting. The next image is from the Monumental Earthworks of the Mississippi Valley by Squire and Davis, which is going to be a book that we'll have linked on our bookstore on the website. It's, if you're interested in doing any research into the amazing phenomena of pre-Columbian earthworks and monumental mound building and so on, this is an indispensable book. So here, this is showing one of the what's called the Milford earthworks. You can see here, probably does not exist except for traces, because now most of this, like the date from this was 1848. So you can see what's happened is the evolution of society, urbanization, agriculture, road and railroad building, all of these things have obscured and erased probably 90% of the earthworks that existed prior to the arrival of the Europeans. However, thankfully to the work of Squire and Davis and others, we have a record of these things. Squire and Davis were surveyors who spent many years making carefully detailed surveys of the extant earthwork structures that still existed back in the pre-Civil War days. And here we see a very interesting, complex. I'll just mention a couple of things here. You see this square here with the open apertures and these mounds just inside the apertures. These apertures were undoubtedly sighting, that if you were standing more or less at the center of this thing and sighting through these apertures, you would be looking at the horizon in various directions and presumably cosmic events. I mean, things like equinoctial and solstitial sunrises and so on. For example, here we have the northeast right here, southeast right here. So it's likely that these could have been solstitial alignments. I don't specifically know on this particular earthwork structure right here, but this is the relevance to our discussion today. This is what's very interesting. This right here, a comet-shaped earthwork. And it doesn't really exist anymore, but thanks to Squire and Davis, we've got this. And this is one of the places where apparent impact proxies were found. So this is a very interesting piece of circumstantial evidence right here. Going on to the next slide here, we see that the Hopewell comet airburst events adds to our growing body of knowledge of catastrophic cosmic events, which led to cultural downturns in ancient complex, sedentary, and agricultural-based societies. So that's just reiterating what we discussed earlier. One of the things here that this time period of 252 to 383 of the Common Era coincides with historically documented near-Earth comets and occurs immediately prior to the cultural downturn of the Hopewell. The airburst event may have created mass confusion and resulting in an upheaval of the social interaction sphere. I think this article is online. The archaeologists got in such an uproar over this that the archaeological establishment put so much pressure on the journal Nature, which is very conservative in its orientation and very much pro-anthropogenic climate change, actually redacted the article. And so if you download it, you're going to get this version where splashed across each page, it says redacted. And again, I think this is part of a paradigm that we're shifting out of to become much more open to the idea of interactions between Earth and the sky, which has not been part of archaeological thinking at all, really, since its inception. But I think the weight of evidence is going to come down and essentially force archaeologists to make some adjustments in their thinking. Now, this next example is very interesting. This is a potentially comet impact in AD 536. Now, this image right here is showing a series of tree rings. So you had this particular article was published, let's see, what was the year again? 2000. It's been a while, August of 2004. And in the abstract, we see here that there was a global climatic downturn, has previously been observed in tree ring data associated with the years AD 536 to 545. We review the evidence for the explanation of this event, which involves a comet fragment impacting the Earth and exploding in the upper atmosphere. The explosion would create a plume, such as was seen during the impact of Comet Shoemaker-Levy 9 with Jupiter. The resulting debris deposited by the plume on the top of the atmosphere would increase the opacity and lower the temperature. We calculate the size of the comet required and find that a relatively small fragment of only about half a kilometer in diameter could be consistent with the data. We conclude that plume formation is a byproduct of small comet impacts that must be added to the list of significant global hazards posed by near-Earth objects. So let's go on here. In AD 536, an event occurred which caused significant climate change. Dendrochronological or tree ring evidence in oak trees salvaged from Irish peat bogs indicates a sequence of colder than average summers at this time. And again, it's referring to our man Mike Bailey. A similar effect is seen in Fennoscandian pine trees. This would be in Scandinavia. And the study of European oak tree data as a whole shows that the event starts in 536 and lasts until 545. Figure 1, which I'll show you in the next slide, shows the typical variation in tree ring widths. North American bristlecone and foxtail pines, Mongolian tree rings, and Argentinian tree ring data all show the same effect. So there was something that happened that was worldwide. The decrease in rate of growth in these years corresponds to a global temperature decrease of up to approximately 3 degrees centigrade. In fact, 536 is noted as one of the coldest 2 or 3 years globally in the last 2,000 years. Figure 2 shows the results for the Irish oak trees and the U.S. foxtail pines. Okay, so here we have, on the left, we have the dendrochronological data showing the decreases in rate. So you can see right here 530, and look what happens between 536 and 540. You'll see the tree ring widths here decrease substantially from their high point down to this low point right here. And then this is the Irish oak trees on the left, and on the right you have U.S. foxtail pine chronologies, and you can see the same thing. You can see this precipitous decline in tree ring width, which is associated with this drop in temperature, global temperature worldwide. Now, what's particularly interesting about this event, 536 to 540 AD, is it happens to be the same dating that's given in the mythical literature about the reign of King Arthur and the quest for the Holy Grail. Okay, that's something to keep in mind here as we go on. So, in the next, continuing here with the article, the surprising result of these calculations is just how small a comet fragment we have estimated was needed to cause the observed effects. A comet less than a kilometer in diameter has not been previously considered to represent a global hazard, as opposed to a local hazard, let alone 1/2 a kilometer across. For example, the UK government's Near-Earth Object Task Force classified impacts from objects in the size range of 300 to 1,500 meters to be a large subglobal hazard, and only recommended monitoring programs of near-Earth objects greater than a kilometer in size. Yet our estimates show that if plume formation is a common byproduct of cometary airbursts, as is believed to be the case, then a relatively small comet fragment can have a global impact or effect. A possible origin for this object could be the Taurid meteor stream. This stream is the result of the fragmentation of a much larger comet some 20,000 years ago. The Earth passes through the Taurid stream in November and June each year, resulting in regular meteor showers, normally consisting of microscopic dust particles. A fragmentation of the stream is thought to have occurred around 500, and it's referencing Klube and Napier from 1984. We're going to talk about their work more in the future. It is possible that a fragment could then have collided with Earth as it passed through the beta portion of the stream early in 536, causing the atmospheric dust veil event. Now, if you recall from our discussion about the Tunguska event, the timing of late June, June 30th, when that event occurred, and its early morning arrival time from the direction of the sun are both consistent with the timing and the direction of from space from which the object would appear, are both consistent with it being a member of the Taurid meteor stream. So they don't present any particular evidence here specifically tying this event in 536 AD to the Taurid meteor stream, but it's possible. And they are speculating that it's possible. So anyways, back to King Arthur. If you recall, interestingly, the whole quest for the Grail was that the land was rendered a wasteland, and the Grail was going to, the finding of the Grail was going to restore not only the ailing king, but the ailing wasteland around as well. Now, the evidence suggests that this 536 to 545 AD event literally devastated the landscape of the British Isles over a broad period, and probably meant there was cultural collapse, agricultural collapse, and so on. So anyways, let's go on with this. That's something we will come back to again I've got this list of things that we're touching upon, but we're going to come back and we're going to address in greater detail in upcoming episodes, because all of these are components of a tremendous story that we're putting together. Other researchers are putting this story together and realizing that this whole phenomena of potentially the interaction between Earth and the cosmos is embedded into the legacy of our inherited traditions, including myths and legends, folklore, and so on, symbolism. And we're going to be exploring that in depth. And that's where this really, to me, gets very interesting, because I think we're going to have to face the fact that, yes, this has been a very important component in the history of our species on this planet. We're not looking at the long-term view of humans on the planet that we now know conservatively is 150 to 200,000 years. We're only looking at the last 10,000 years here, roughly. Okay? And we're discovering that it's probably a major factor in understanding events that have transpired here below that would have had tremendous consequences for human lifeways and societies and so on. Okay, so here's the work of Bill Napier, who's done some very important stuff. This is going back to 1997. Comet catastrophes, cosmic dust, and ecological disasters in historical times, the astronomical framework. This is from the proceedings of the Second Society for Interdisciplinary Studies, Cambridge Conference, 1997. And he's making reference here back to the Taurid system. He says that the available data from fireball and comet observations, meteorite impacts, small lunar craters, and the current near-Earth environment are assembled to yield a coherent picture of the interface between the Earth and its current interplanetary environment. The Taurid complex of meteors, meteoroids, asteroids, and comet Encke has probably been a significant and regularly visible celestial hazard from the last ice age through to the present day. These data lead to the expectation that history has been punctuated by 1. Tunguska-like impacts, singly or as part of fireball swarms, freezing events of decadal duration due to cometary dusting of the stratosphere, and 3. Occasional disastrous inundations of coastal areas due to small body ocean impacts. These are 3 things to really consider and keep in mind. Tunguska-like impacts, now we saw a 1908 event was a single object. However, there's evidence from the strewn fields and eyewitnesses from other evidence that these things can occur in clusters or swarms, if you will. When we talked in one of our earlier episodes about showing how a lot of comets have now been seen to disintegrate. And again, we'll be covering all of this in these upcoming episodes because what we want to do is make a very concise and coherent presentation of this evidence that, in my mind, demands a paradigm shift. So part of one of our goals here is to try to get this information and this data collected into a single source so that one can go through this material, find links for further research, in-depth investigation, and so on, and start bringing this knowledge and this information to the forefront of our thinking about not only our past, but even perhaps more importantly, our future as a civilization. Okay, after a little break, welcome back to the second half of this podcast dealing with the role of hypervelocity impacts of various kinds in human history and through the period called the Holocene. So we're going to continue looking at some of the evidence, not all of the evidence that's out there, but we're going to be continuing to look at the evidence that there have been more impacts in the last 10 or 11,000 years than previously recognized by mainstream science. So let's just get right back into it. So we have more evidence for Holocene impacts. So there's a meteorite impact crater field that's been almost certainly proven in Bavaria. So this is just a preliminary report on this particular event. Let's dive in and take a little deeper look. This appeared in the journal Meteoritics and Planetary Science in 2005. As it says, the abstract is available online. I think maybe the whole article might still be available. It's worth a read. So, quoting now from the article, numerous circular depressions north of Burghausen in eastern Bavaria, with diameters ranging from meters to tens of meters in size, dispersed over an area of at least 11 by 7 kilometers, are suspected to have an extraterrestrial origin, since they resemble other small meteorite impact craters. The depressions are bowl-shaped, have high circularity, and a characteristic rim. Most of them were formed in unconsolidated glacial gravels and pebbles, intermixed with fine-grained sand and clay. Now, the fact that they were in glacial gravels and pebbles then, of course, implies that it's younger than the end of the last ice age, which deposited those glacial gravels. An evident archaeological or local geological explanation for the origin of the craters does not exist. A World War I and II explosive, which have been proposed, origin can be excluded, since trees with ages exceeding 100 years can be found in some of the craters. One crater was described as early as 1909. Carbon-14 dating of charcoal found in one crater yielded an age of 1,790 plus or minus 60 years. Hence, a formation by meteorite impacts that occurred in Celtic or early medieval times should be considered. A systematic archaeological excavation of some structures and an intensified search for traces of meteoritic material are planned. I've not followed up on that to see what the latest would be. If any of you listening here are so inclined, please do that and let me know what you find. But let's go on here. This appeared in the magazine The Atlantic, a popularized version of some of this by Greg Easterbrook. And he says that the odds that, now this is wild stuff here, the odds that a potentially devastating space rock will hit Earth this century may be as high as 1 in 10. So why isn't NASA trying harder to prevent catastrophe? Good question. Okay, so breakthrough ideas have a way of seeming obvious in retrospect, and about a decade ago, a Columbia University geophysicist named Dallas Abbott had a breakthrough idea. She had been pondering the craters left by comets and asteroids that smashed into Earth. Geologists had counted them and concluded space strikes are rare events and had occurred mainly during the era of primordial mists. But Abbott realized this deduction was based on the number of craters found on land. And because 70% of Earth's surface is water, wouldn't most space objects hit the sea? So she began searching for underwater craters caused by impacts rather than by other forces, such as volcanoes. What she found is spine-chilling. Evidence that several enormous asteroids or comets have slammed into our planet quite recently in geologic terms. Abbott believes that a space object about 300 meters in diameter, that's over 1,000 feet, that's many times larger than Tunguska, hit the Gulf of Carpentaria north of Australia in 536 AD. Now notice the correlation of dating events there, right? An object of that size striking at up to 50,000 miles per hour could release as much energy as 1,000 nuclear bombs. Now, we know that the energy release of 1,000 nuclear bombs is going to have global consequences, no doubt. The term nuclear winter came about because scientists in the 80s were studying the effects of cosmic impacts and realizing that the fires, the initial fires, the secondary fires, the dust loading of the atmosphere, and so on, would cause a precipitous decline in global temperature. And that would lead to what they called the cosmic winter. That in turn led to the realization that the detonation of a substantial number of nuclear weapons would have the same effect. And that is something we need to be very concerned with. And there's an implication to all of this that I think needs to be emphasized, right? Now, before we do that, I just want you to notice down here, 300 meters is 492 feet, and that's about 280 times the volume of the Tunguska object, right? Now here's the thing that we have to address as we get into this idea that cosmic impacts during our own historic times may be way more common than we'd previously expected. And we know that there have been, and I'm going to be presenting this in one of the next episodes, the number of fireball explosions that have been documented by the Department of Defense. Now, the concern, and it's a very legitimate concern, is that in times of heightened international tension, such as we're entering right now, as you know, the Biden administration is pushing us into an escalating war against Russia, is that during these times of heightened tension, if there's a fireball case, and this has actually happened historically, number of fireball events have actually been mistaken for nuclear missile launches. Now, this is something to keep in mind that nobody's talking about this. I mean, there was no mention of this during the debates the other night that we saw. Neither of the Republicans, maybe a few of the Republicans are addressing this. I don't see any Democrats at all because they're fully on board, again, with the anthropogenically caused climate crisis. We know that they're pushing for roughly over the next 10 years to spend $1 trillion or more on remediation for a completely contrived climate crisis, which again, not even part of the debate, but it needs to be part of the public debate that we need to have. And we're going to be having that debate in this podcast. We're going to be discussing these things in depth because they need to be discussed, not ignored, not pushed under the carpet, not put on the shelf in the closet and close the closet door. These need to be in the forefront of our policies and our decision making going forward. I would like to mention that one of our original sponsors at Cosmographia, CBD from the Gods, is following us here to our new podcast, Squaring the Circle. As many of you know, I've been using their products for going on 4 years now, and having tried a number of CBD brands, CBD from the Gods seems the most effective for my needs, which is primarily as a sleep aid and as a remedy for inflammation and associated pain. I use both the oil and the salve. My wife also likes their products, especially the salve, which alleviates the pain in her hands, which is the result of working for years as an electrician. If you've been thinking about trying a CBD product and experiencing the benefits for yourself, give CBD from the Gods a try. To learn more and see their product line, check out cbdfromthegods.com. Any purchase of their products helps our efforts here at Squaring the Circle to realize our goal of making this world a better place. Thanks. This is again from 2004, from the Lunar and Planetary Science, number 35. They have conferences every year. Sand lobes on Stewart Island as probable impact tsunami deposits. So if you have an impact, obviously, into land, it's going to produce one suite of potential effects and consequences. It's going to be very different signature from one into the ocean. Into the ocean, you're going to have two primary effects. One is going to be the injection of large amounts of water vapor into the upper levels of the atmosphere, which then will circulate around and rain out over a period of days to weeks, causing torrential rainfalls wherever the plume of water vapor moves to. And the other effect is going to be large-scale tsunamis. That's what we're going to look at here. And it's only going to be a brief introduction to this phenomena of tsunamis. There's whole new literature and scientific understanding of tsunamis that's underway right now. Tsunamis are an underrated hazard. About 500 years ago, a cosmogenic tsunami produced a minimum run-up, get this, 130 meters. 130 meters, let's convert that to feet, and that works out to be about almost 500 feet in Jervis Bay near Sydney, Australia. The probable source crater for this event is Mahuika crater at 48.3 south latitude and 166.4 east longitude on the western edge of New Zealand shelf. Mahuika impact crater is 20 plus or minus 2 kilometers in diameter. That's about 12 to 13 miles in diameter. So that's a pretty substantial crater. Anything causing a crater that large is going to have global effects. And it's less than 1,000 years old. It has a tektite field that is found in surface sediments located to the southeast of the crater. Tektites are prima facie evidence of impact origin. Well, when one of these upcoming episodes that I keep referring to, we're going to look at impact proxies in more detail. The microspherals, the iridium deposits, platinum group metal deposits, magnetic grains, tektites, microtektites, and so on, and the shocked quartz, the various types of proxies that we can use to determine that there was, in fact, a hypervelocity impact. Although Jervis Bay is over 1,500 kilometers from the Mahuika crater, Stewart Island is only about 200 kilometers northeast of that crater. Consequently, the tsunami run-ups from the Mahuika impact should be higher on Stewart Island than in Jervis Bay. We are conducting a field survey in February 2004 to determine if the maximum elevations of the sand lobes represent tsunami run-up or wind-blown deposition. Now, what's interesting here is that, again, you have sort of the catastrophist wing on one side and you have the gradualist wing on the other side, who've been arguing that these phenomena that I'm about to show you some examples of here is caused by wind and not water. And I think we can demonstrate pretty conclusively that they're definitely the depositional consequences of great tsunami run-ups. So in preparation for our field program, we have obtained orthographic aerial photo coverage of the field area. The aerial photos show many sand lobes that run roughly west to east but meander along the strike. Now, this was in 2004. We now have Google Earth with updated imagery, so I'm not using the orthographic aerial photos. I'm using Google Earth because they're much more impressive. So Edward Bryant, he's one of the key researchers in the effects of great tsunamis. This is from the Journal of the Siberian Federal University, Engineering and Technologies. Interestingly, some of this stuff has to be published in the foreign press because of the conservative nature of the Western and American press, which is still dominated by the gradualists and those who are, dedicated to avoiding the implications of catastrophe in Earth and human history. But we have here this paper was entitled Tsunami Chronology Supporting Late Holocene Impacts. Let's take a look. So the Holocene Impact Working Group has identified the location of at least 8 impacts into the world's oceans in the late Holocene. Each of these was capable of generating a large tsunami that should have left a geological footprint on adjacent shorelines. We have identified from shoreline tsunami deposits 5 known impact events, 2 of which are associated with impact craters identified by the Holocene Impact Working Group. The other 3 are associated with legends and historical descriptions. This paper presents the chronology of tsunami events in New South Wales and Western Australia on opposite coasts of Australia and in the UK that are linked to impact events. So we'll take a brief look at this. Here's New Zealand. Here's what is referred to as the Mahuika crater. Here's Stewart Island. You can see it's right off of the south coast of the southern island of New Zealand. Okay, and in the next episode, I'll show you an example of the kinds of things, like this would be a microtectite. It was found in a dredge that was formed from the ocean bottom between Stewart Island and the Mahuika crater. There's many examples of the finding of similar things. So this is what we call a microtectite. Let's take another look here. So here's Stewart Island off the southern tip of New Zealand. And here we have a closer up view, and you can see here each of these numbered 1 through 6 represent tsunami run-up deposits, right? So we're going to take a closer look at some of those. Let's just scroll on here and see what we got. Okay, here's sand lobes on Stewart Island. Now this is where you can see the tsunami run-up has washed up and deposited sand. So the water runs up, deposits its sand, and then flows back into the ocean. So you can see down here, this is 100 meters scale down here. So this is about 1,000 feet inland. But this isn't even the most impressive. Let's go to the next one. Here you see sand lobe deposit number 4. This is number 3. So if you go right up here, you can see this smaller one right here, number 3, is this one. And then number 4 and 5, you see down here. So here's number 4, sand lobe deposit. And you can see here, the scale bar down here is about 200 meters. So this is probably close to a mile inland, and you can see that the water has run up right over this ridge. The tsunami has run up right over this ridge and down the other side, and then when it drained off, it left all of this material here in its wake. Okay, so here you see 4, and then you see 5. So here is a closer up view of 5. And again, look at the bar down here is about 1,000 feet. So this is close to 2 miles inland. So this would have been a very large tsunami wave making landfall here. So here you can see 4 and 5 from kind of a more distal view. And this is interesting because some of you have been watching my presentations and stuff are going to know what imbricated boulders are. These are boulders that have been stacked up by water. Now this is on the Little West Island. It's about 25 feet above sea level, Gulf of Carpentaria. So this would have been a tsunami in the Australia. And you can see here that it basically ripped up these boulders and dumped them on the shoreline and left them stacked up in this imbrication, it's called, where they're stacked like this. Here's another view of the same thing. You can see again here at the base of this cliff, these boulders did not come from this cliff. These boulders were ripped up from the bedrock some distance off the coastline and washed ashore by a giant wave, a tsunami wave, that then dumped them here. And then here's on the island of Tongass. Here's a giant tsunami deposited boulder. I don't know the origin of this one, but we are going to be looking in our comprehensive overview of catastrophism. We will most definitely be including in-depth investigations of all this new incredible research that's coming out about tsunamis and the scale of some tsunamis in the past. I mean, this is a huge, huge boulder right here, and you have to just try to imagine the power of the wave that could bring this thing ashore and deposit it. Okay. Now, the argument is that a tsunami wave of this magnitude is beyond that one would be expected to result as a consequence of an earthquake or a seismic event, right? This is something that's perhaps in a separate category of tsunami, which then leads one to, like what Bryant said in this earlier slide that I just showed, is that it's likely that waves of this magnitude are produced by impacts of, asteroids or comets into the ocean. So here's some of the work of Dallas Abbott using depth sea core samples to verify the sources of Holocene age megatsunami deposits. Although conventional astronomy suggests that large, greater than 1 kilometer impactors hit the Earth once every 300,000 years, we have assembled evidence for at least 3 large oceanic impacts during the last 11,000 years. The 1.5 kilometer Deluge comet produced the 29-kilometer Burckle crater, which is astronomically estimated to be 4,800 years old. Now, this has actually been redated since this to be several thousand years older. We'll be coming back to this in these upcoming episodes. This, and particularly when we talk about the traditions of myths, legends, and stories and so on, we're going to look at some of these stories of great floods, particularly even the biblical flood, which, a circumstantial case can be made that it might have been the result of a major impact into the Indian Ocean. And this is where the Burckle crater is found. The impact may be responsible for ancient legends about torrential rainfall, hurricane-force winds, and coastal megatsunamis. The deluge was followed by a period of dim sunlight and colder climate. Around 1440, plus or minus 15 years AD, a approximately 1 kilometer cometary impactor produced the 20-kilometer Mahuika crater off the coast of New Zealand. This impact may have produced 130-meter run-ups in Jervis Bay, Australia, and may have caused the Maori to move inland. We have also found a pair of craters in the Gulf of Carpentaria that are 18 and 12 kilometers in diameter. This impact may have produced 130-meter run-ups in Jervis Bay, Australia, and may have caused the Maori to move inland. And also the Maori have some very interesting traditions about floods themselves. We have also found a pair of craters in the Gulf of Carpentaria that are 18 and 12 kilometers. 18 kilometers, that's going to be close to 10 miles. 12 kilometers, that's going to be close to 7 or 8 miles in diameter, and appear to date, again, 536 plus or minus 200 years AD. If so, their source bolide was over 600 meters in diameter. In addition, we have candidate impact events in the Mediterranean Sea, the North Atlantic, the North Sea, off the coast of Vietnam, off the China-Korean border, on the Kerguelen Plateau, in the Caribbean, and off the coast of Denmark. Now, the one off the coast of Denmark could be very much associated with the 536 AD as well as the Gulf of Carpentaria one. If that's the case, we now got very closely clustered impacts both in the northern and hemisphere that could have led to some of the legends about the wasteland and so on that we're going to be talking about. There's a distinct possibility that the equatorial, that is between 30 degrees north and 30 degrees south, candidate impact events may be related to the climate downturns that are recorded in tree ring records. The formation of the Vietnam crater may have produced a rain of dust that is described in the Chinese historical record and is inferred to be related to a major climate downturn. There was a major historical dust event, veil event, that lasted for 18 months during the 536 and 537 AD that may be related to the 536 to 541 AD period of colder climate. Neither of these dust veil events is associated with a volcanic eruption. Now, this is important because this might be the alternative explanation. But if there's no evidence of volcanoes erupting, then what are we left with? We're probably left with impacts. Using deep sea core samples to verify a crater candidate for the climate downturn lasting from 536 to 545 AD, we have collected data from the GISP-2 core, this is the Greenland Ice Sheet Project 2 core, ice core, confirming that the layers dated from 536 AD to 542 AD contain high abundances of impact ejecta. Within the samples we have examined so far, there are 2 apparent peaks in the abundance of impact ejecta, the most recent around 541 plus or minus 2 AD. This layer contains a radiolarian fragment, impact glass, and silicate impact spherules. This suite could be produced by a marine impact event. Because all dust falls out of the atmosphere after 4 years, our data require at least 2 impact events. And again, this could be the one off the coast of Denmark and the one off the Gulf of Carpentaria. Mike Bailey believes that a large impact occurred near Ireland around 540 AD. The impact produced atmospheric effects, seiches and lakes, and narrowest rings in trees in northern Europe. Bondevik and others et al. Found evidence of a tsunami-generating event in the North Sea around 1,500 years ago, and we have found a crater candidate, Grendel, that fits the possible source area of their North Sea tsunami. And here we're going to look at a bathymetric map showing where Grendel, the location of Grendel just off the coast of Norway. A is a bathymetric map showing the Grendel crater candidate. You can see right here in the blue circle. B is the direction to the source of the tsunami. Look at this arrow right here, right? So this is showing the direction from which a tsunami came. A, B, and C. Notice here, B up here, here, and both of those here. And where is C on here? Okay, so yeah. So here's A, B, and C. So look at the direction now. So this is showing the direction from which the tsunami came that has now been documented on the shores of the UK and up here and then off the coast of Denmark. So I don't know what's found on Norway, but you know, a lot of this is initial work that hasn't been followed up on simply because the funding is not available for this kind of work. This is one of the points that Graham Hancock and the members of the Comet Research Group have made over and over again, is that mostly this is funding that's having to come out of pocket from these researchers because the hundreds of billions of dollars are not going to this kind of research. It's going to make the case that humans are the cause of all climate change. And this is one of the things that I've harped on over and over again for years now, and is something that under a Harris presidency is going to continue on. She's already talked about the enormous amount of money she plans to spend on remediating a climate crisis that doesn't exist. And you can take issue with that, but we will definitely be addressing this whole issue in upcoming episodes, so stay tuned for that. Let's wrap up here. We'll look at a couple more slides, and we're going to wrap up this episode. This is evidence from that Burckle crater that was dating to about 4,800 years ago that I said looks like it's actually a little older. And there are 3 great run-ups that have been now discovered here and documented. Finambuzi chevron, Ampalaza chevron, and the Faux Cap chevron. Now, a chevron, you know, is sort of a V-shaped. Canadian geese fly in chevron formations. Sergeant stripes are chevrons. And chevrons seem to be, when you have an overwash of a tsunami, depositing material by the inland flow, and then the outland back seaward flow, it shapes what would normally be simply current ripples, giant current ripples, into these chevron formations. And you're going to see here in a second what they look like. So this shows the location of the Burckle impact crater. Australian chevrons are on this side, and Madagascar chevrons over here. And we're going to be looking, we're going to be devoting at least 1, maybe 2 episodes to unpacking this whole phenomena of gigantic tsunamis in the past. And when we do that, we're going to be looking at the evidence for possible impact-produced tsunamis. Anyways, here's the location of the Burckle crater. We're going to just, for this, to conclude this episode, we're going to look at the evidence for tsunami run-ups here right on the south coast of Madagascar. So let's go to the next slide. And here you can see giant tsunami deposits on the southwest coast of Madagascar. This is the Ampalaza group. If I go back here, you'll see the Ampalaza chevron is right here. In the middle, you have the Phenombosi chevron, and down here you have the Focap chevron. So this is looking at a closer up of the Ampalaza, and you can see right here the run-up. The great wave came up here and then flowed back down. You can see the enormous amount of sand from the overwash of the wave here. There's more up here, but we're going to zoom in here and take a closer look. So here you see the quote, "Scientists in the working group say the evidence for such impacts during the last 10,000 years, known as the Holocene epoch, is strong enough to overturn current estimates of how often the Earth suffers a violent impact on the order of a 10 megaton explosion. Instead of once in 500,000 to 1 million years, as astronomers now calculate, catastrophic impacts could happen every few thousand years." Now, since this was written, the evidence has continued to accumulate that this is a more realistic time scale, every few thousand years. Now, take a look at this giant wave deposit here. You can see the chevrons, you can see the water washed in. Then right up here where it reversed, it deposited the finer grained sandy sediment, and then it flowed back out. And this backflow seaward is what shaped what would have been current ripples into these chevron shapes. So first you had the water coming in, then you had the water flowing out. Okay, let's look at the next one. So this is the Phenombosi group of chevrons. And what's interesting here, and this is really driving home the magnitude of these waves. You can see all along here, the waves washing up. You can see the chevrons all the way up into this area. There was the huge major wave that made landfall, came all the way up here. There's an escarpment all along here, and we can see that there are wave deposits, not only on the coastal lower land here, but on the upper area above the escarpment, which we see very clearly delineated along here. It's much clearer down here than it is right here, because the escarpment, when that wave hit the escarpment, it pretty much obscured it with both erosion and deposition of the material that was being washed ashore in the wave. Okay, let's go to the next one. And here you can see clearly from above that the major wave made landfall here. This is the escarpment. Now, this red box right here is going to show you there's a photograph taken by Dallas Abbott that's coming up here, which is looking at the escarpment, and you can get a sense of how huge this wave had to have been. Let's go to this one here. You can see, again, here's the escarpment, or the fault scarp. There's a fault line right along here, and you can see the wave washed up here on top, and you'll notice that the deposition is different. Why? Because, well, most of the material was deposited on the lowlands on the coastal side of the escarpment, and finer material deposited on the top end. Now, going back again at this red box, the photograph I'm about to show you is looking north here at this section right here at the escarpment, and here you can see it. So here's this looking northwest, showing the fault scarp separating the elevated plateau region portion of the Phenombosi chevron from the lower part, the lower coastal plain. The near cliff encompasses chevron deposits that are continuous on the coastal plain and discontinuous along 9 kilometers of the uplifted wall of the fault scarp. The far cliff, this one here, has ubiquitous chevron deposits extending from the coastal plain down here to the top of the elevated plateau. So the height here, again, this is that huge run-up wave of 130 meters minimum, and we calculated at 130 meters was up to like 450 feet. So you got to picture the magnitude of this wave that made landfall, that was able to overtop the fault scarp here. This was an enormous wave, and anything that would have been along this coastal region here in the vicinity of this wave making landfall would be completely erased, 100% from existence. We've already looked at this. I think well, no, this was actually an article that appeared in the New York Times, and this is where we're going to end it for this episode. At the southern end of Madagascar lie four enormous wedge-shaped sediment deposits called chevrons that are composed of material from the ocean floor. Each covers twice the area of Manhattan, with sediment as deep as the Chrysler Building is high. On close inspection, the chevron deposits contain deep ocean microfossils that are fused with a medley of metals typically formed by cosmic impacts. And all of them point in the same direction, toward the middle of the Indian Ocean, where a newly discovered crater 18 miles in diameter lies 12,500 feet below the surface. The explanation is obvious to some scientists. A large asteroid or comet, the kind that could kill a quarter of the world's population, get that? A quarter of the world's population, smashed into the Indian Ocean 4,800 years ago, producing a tsunami at least 600 feet high, about 13 times as big as the one that inundated Indonesia nearly 2 years ago, which would have been 2004. The wave carried the huge deposits of sediment to land. Most astronomers doubt that any large comets or asteroids have crashed into the Earth in the last 10,000 years, but the self-described band of misfits that make up the 2-year-old Holocene Impact Working Group say the astronomers simply have not known how or where to look for evidence of such impacts along the world's shorelines and in the deep oceans. Scientists in the working group say the evidence for such impacts during the last 10,000 years, known as the Holocene epoch, is strong enough to overturn current estimates of how often the Earth suffers a violent impact on the order of a 10 megaton explosion. Instead of once in 500,000 to 1 million years, as astronomers now calculate, catastrophic impacts could happen every few thousand years. To reiterate that point, the last slide I think we'll look at here is a giant tsunami deposited erratic on India, near Mahabalipuram, about 30 miles south of Chennai on the eastern side of the Deccan Peninsula. This could be also a deposit and evidence of the Berkeley crater tsunami. We'll leave it off for there. In the next episode, we're going to continue with our looking at mythology and legends and folklore and so on. This one that I just pulled up here is interesting because this Tunguska-sized airburst that destroyed Tel el-Hammam, a Middle Bronze Age city, has all the earmarks of being the source of the legend of Sodom and Gomorrah. So we will pick up this in the next episode where we start dealing with the lore that we've inherited from our ancestors in the past, because it has been commented, in fact, some of the critics I've gotten when I've been presenting this, particularly a few years ago, 5, 10 years or longer ago, well, if there was all of this evidence that impacts, hypervelocity impacts, had affected earlier cultures and earlier civilizations, well, then we would have a much more extensive record of it. Well, my response now to those critics back then and now is simply this: we do have the record. We do have the record. You're just not interpreting it properly. What you have to understand is that the myths, the legends, the folklore, the symbols that have been used within these stories, that's the record. That's the record right there. And it's very extensive. And to me is one of the most interesting parts of the study of this whole phenomena. And if you've been following these episodes up to this point, I am hoping that you've got a good solid foundation now. And if you don't, please go back and rewatch some of the earlier episodes where we talk about Tunguska, where we talk about near misses, where we talk about some of these things. Then when we look at the legacy of the ancient traditions, you might see it with new eyes. And once you realize that the whole language in which these experiences have been encoded is the language of symbolism, it's the language of myth, then I think you'll begin to appreciate that, yeah, here's a whole nother component of of evidence that supports this idea that the cosmos have played a much larger role in our own history than have been previously recognized by historians, prehistorians, archaeologists, and so on. We already recognize and admit that it's played a much bigger role in Earth history than had been imagined a generation, 2 generations ago. In fact, it may play the fundamental role in Earth history when we talk about mass extinctions and ice ages and climate changes and massive episodes of volcanism and so on, right? All of these things are now being tied into as consequences of hypervelocity impact. What we're just in the very beginning this stages is recognizing this as a factor in our own human story on this planet. I think that needs to be rectified, and that's going to be one of the goals that has motivated us up to this point and will continue to motivate us. And we are going to also be considering some of the policy and political ramifications of this new knowledge, because it certainly is not part of the zeitgeist or the mental thinking of most of the people in the political realm. We're also going to be looking at, and this is a little further down the line, but the whole phenomena of unidentified aerial phenomena, or also unidentified anomalous phenomena, as it's called. And is there a possible connection or correlation? Because, you know, again, we're talking about activity and things that are happening in the celestial realm, in the sky, and people's relation to that. Is there a possible correlation, let's say, between the kind of phenomena that has been occurring and has been pretty solidly documented now up to this point? Lou Elizondo's new book has just been published that dives into some of this phenomena. I would submit that there may be a connection, and we can explore that, and we'll be exploring that in these upcoming episodes that I keep talking about. So anyways, I think we'll stop there for now, and we're going to pick this up again, pick up this thread, diving into the ancient traditions and mythology and so on. And maybe by unpacking that, we're going to discover that there's a whole dimension of meaning and significance to this legacy of our inherited wisdom and knowledge of the past that has been completely overlooked up to this point. So I hope you come back and continue on watching this. If you are so moved, please subscribe. We put out a newsletter every month that I put a synopsis of cutting-edge scientific discoveries that might be of interest to people who watch the Cosmographia podcast or this podcast. And every month it comes out, we'll soon be archiving a couple of years' worth of these that will become available on our new website that's being built as we speak. So please stay tuned, come back, check in the near future, and we'll have more of this exciting information to present to you. Thank you. See you next time.